Hey everyone, welcome to the ninth video in our series on the reactions of chapter 8. So in this video, it's going to be quick, just like the last one over carbines, but in this video, we're going to be talking about Syn-Dihydroxylation. So let's write that. So this is Syn-Dihydroxylation. Okay, so Syn-Dihydroxylation, obviously by the name, this reaction is syn addition. And also, this reaction forms both enantiomers. So that's all we had to really worry about here. So there's two different ways to do this, okay? So the first way is with cold or dilute, well, not cold or, cold and dilute potassium permanganate. So that's potassium permanganate. And the other way to do it is with OSO4, which is osmium tetroxide, okay? So we'll talk about both of these, but they both do the exact same thing. No difference, okay? So let's do this alkene. We'll do a couple of examples. But so with cold and dilute KMNO4, so we have dilute KMNO4 on top, so potassium permanganate, okay? And then on bottom, we usually have water, NaOH, and it's cold, okay? So what this does is it adds two hydroxyl groups, syn. So these are both adding to the same side, okay? So each carbon in the double bond gets a alcohol on it, and that's it. Okay, that's literally it. So it's a pretty simple reaction. The only time where it gets a little, I mean, even a little tiny bit more complicated is if we're forming a chiral center. So again, we're going to use KMNO4 and then H2O, NaOH, cold. And what this is going to do is still add them, except the OHs are going to be syn to each other, right? So OHs are syn, and then we also get the enantiomer of this one, right? Like I mentioned, we also get the enantiomer. So syn addition, and we get the enantiomer, all right, with the cold potassium permanganate, all right. There's not really anything else that complicates this at all. This is basically, this second one is about as hard as this reaction is ever going to get. So now let's look at the osmium tetroxide. So we'll do this one again with osmium tetroxide. So osmium tetroxide is two steps. So the first step is OSO4 with pyridine. And then the second step, there's variations that the second step can have, but one version of it is NaHSO3 with water. Okay. And this does the exact same thing as cold potassium permanganate. The only difference is that osmium tetroxide has a better yield than the cold potassium permanganate, but osmium tetroxide is also very toxic and it's carcinogenic. So you have to weigh that risk whenever you're doing this reaction. Okay. So whether you want to get a better yield and risk possibility of something bad happening, or if you just want to get a bad yield and play it safe. So So again, osmium tetroxide with NaHSO3 and water. Osmium tetroxide is also expensive. So sometimes we don't want to spend money on osmium tetroxide, even if we're fine with taking the risk. Sometimes it's just too expensive. So that can also be a barrier sometimes. So again, this does the exact same thing. There is literally no difference at all. And we don't need to worry about the mechanism. So this is all that we need to know about this one. And it forms both enantiomers, just like the last one. And that's it. So this is this entire reaction. Like I said, not too complicated. This is as complicated as it will ever get. And so that's it. So hopefully this video was helpful. In the next video, which is going to be the very last video that we're going to do over the reactions of chapter 8, we're going to talk about hot and concentrated potassium permanganate and how that does oxidative cleavage. And we're also going to talk about ozonolysis, okay, which is also a form of oxidative cleavage. So hopefully you'll join me for that. And hopefully this video was helpful. I will see you next time.